Hello, everyone. Welcome at the NVH webinar of the SIA. So we have many people who are connected today from everywhere via the net, from LinkedIn, from YouTube, and possibly also from Facebook. We are all together today to discuss a topic, an important topic, which is how we can evaluate automotive acoustic comfort. So to discuss this topic, we have a flow of people who have been invited. We have people from the automotive industry. For example, we have Anne Sanon, who is an NVH expert, senior expert at Valeo. We have Matt Monder, who is an NVH team leader and technical specialist at Ricardo UK, who will walk us through also their studies. We have Laurent Gargliadini, who is an NVH expert at Stellantis. Min Su, who is NVH senior expert at Valeo China, to give us some flavor about China. And we wish we had Isabelle Chaillet-Mauvarin, who is from Renault, wanted to join us, but unfortunately couldn't make it in the end. So anyway, Isabelle has sent us some questions, and we will use that to make sure that she can participate to this webinar. So outside the automotive industry, you have people from other horizons, so other industries. So the first one is Rosen Nicole. Rosen Nicole is a research engineer in acoustics in the telecom world. So she is from Orange. We have Fabrice Aubin, who is an NVH acoustic specialist from the railway world in France, from SNCF. And we have, to finish, Etienne Pariset, who is a professor of the very famous engineering school in France called INSA, which is located in Lyon. So this is our virtual, let's say, round table. The process will be very simple. Some of the presenters, we have 4 to 5 presenters maximum. They will present the topic. Based on their presentation, questions will occur, followed by discussion. Question will come either from the table or will come from the net. So that is the reason why you can see here on the screen. You may ask also your questions directly either from LinkedIn and so on by chat, or to send by email at the address that you can see here under the screen. So to start our webinar, we will start with Laurent Gargliadini. Laurent Gargliadini, as I told you, is from Stellantis France. So typically one of the biggest automotive companies here in France. And Laurent will speak about the comfort in general and the NVH comfort in particular. So Laurent, the floor is yours. You can present, and once you finish, then we will start with the first questions.
Okay, thank you, Charles. So I think now you can see my presentation. There are just some preliminary reflections I had about the notion of comfort, and especially acoustic comfort. So let's first, a few remarks on what is comfort in the automotive world, and what's the part of NVH in this global comfort. So first of all, comfort is very relative. It's something subjective. It's maybe also cultural. And so to address this issue, we just refer to the market, and we do a lot of benchmarking and test with real customer or experts to assess what is a comfortable car in general. And of course, NVH is just one of the components of the comfort. You may have thermal comfort, you may have vibration comfort, seating comfort, access comfort. Okay, so this is a wall. And NVH comfort, as well as other comfort components, appears to be highly correlated to the vehicle price. So the most expensive the car, the highest the comfort of the car. And it's sometimes difficult to distinguish between the cause and the consequence. Is a expensive car comfortable because it's expensive? uh, or every expensive car is considered as comfortable. When you measure the car, sometimes you have real surprises. And from a very general point of view, we also have to face this um, different views we may have in between experts and customers. And of course, as engineers, we are considered as experts, but the end user is the customer, and he may have very different perceptions of things. If we come more eh, on the real acoustic comfort, um, we have to uh, think about what we're talking about. So we may talk about comfort, of course, this is the topic today, but sometimes when we talk of comfort, we also talk in negative way in discomfort. And we will also have some discussion about sound quality, and all those words may be connected or not, depending on the context, on the stage in the design process where you may work. Generally, we have to address two kinds of issues. Long-term issues, what happens when you stay a long time in your car, and which will be more related to annoyance. And short-term issues, small noise that just disturb you and related more to disturbance. And there's a balance between the two aspects. And of course, in a good car, you're not disturbed and you're not annoyed. Um, then if we talk of noise, there are different kind of noise in a car. We distinguish between functional noise that cannot be avoided, like aerodynamic noise. If because of the speed, the air is moving and there's some turbulence and some aerodynamic noise. Or rolling on a road, you have some rolling noise. So this is functional. This is directly related to the function. But there are also some dysfunctional noise that we hope would not exist, and related to some misfunction of some parts. Squeak and rattle typically is a dysfunctional noise. It's shocks between parts, and if the engineering was perfect, there would not be any dysfunctional noise. Um, then a last remark. Of course, all those noise have to live together, and some are masking others. And so we maybe will talk in the next presentation of the masking effect. So the fact that a louder noise will mask some smaller noise. And if we decrease the noise level, in fact, we increase the number of issues. The lower the rolling or aerodynamic noise, the highest the number of possible small disturbance that will emerge from the background noise. So uh, decreasing the noise is not always a good thing for the overall sound quality of the car. Okay, so that was just introducing remarks, and I'm ready to answer to your questions.
Okay, very interesting. Thank you very much, actually, Laurent, for this presentation. By the way, I just realized I did not introduce myself. My name is Charles Sagna. I'm the director of the Thermal Academy at Valeo, and I was chosen to moderate these debates. So within the debates, I can see I have a first hand, which is reason, which is from Rosen Nicole. So Rosen Nicole, as I told you before, Rosen is a research engineer in acoustics at Orange, so telecom. So Rosen, you can raise your question.
Thank you, Charles. Yes, I was wondering whether there are studies on intercultural differences of user expectation in terms of automotive acoustic comfort. And if so, to what extent are these differences taken into account by industry?
Um, we strictly speaking, we never had such studies, but of course we have engineering centers in Asia. So we of course ask the question: is there any things we have to change in the design of the car to address Chinese customer requests? So I think about 10 years ago, we had a study where we tried to evaluate a panel of cars. I think there were 5 cars, our own cars and some competitors' car, with both in China and Europe, with 2 panels, one expert panel, one customer panel. And the results were really surprising because it happens that there's much more difference between customers and experts than between customer or between experts. Experts, they provide the same results because they have been trained together and they use the same engineering rules. So they had really the same ranking of the car. And very surprisingly, results between Chinese and European customer were very similar. And I would say that for sure there are some differences in the way the car is operated. The operating conditions are already different, for example, in Asia and Europe. And also the environmental conditions may be very different. So it's not the same experience. So different experience, different answers. But from a strict NVH point of view, what is annoying? What are the critical levels? It, for us, it's very similar. And there's no difference in the way of engineering cars. And we may have some differences, for example, for the same car in the quality assessment in Europe and China. But I don't have any example where it's just related to a difference of perception of the customer. Most of the time, there's a manufacturing issue. It's not the same factory, different issues, and the problem raised in one area, and it's because there has been some change in the manufacturing.
Thank you very much, Laurent. Since we have many questions
Yes,
showing up,
actually.
maybe any of you guys have another question? Anybody wants to raise a question at the round table? Anne is raising her hand. So Anne Sanon, NVH expert at Valeo, senior expert. We
Your
can't
microphone,
hear.
Anne.
Sorry. To
Okay.
evaluate the acoustic comfort inside the car, how can the R&D noise experts' subjective evaluation match with the marketing strategy and the marketing subjective evaluation? So it's not between end customers, but between R&D experts and marketing.
So as any company, I assume we have a very clear engineering process that starts with marketing demand. And then we have, of course, some engineering indicators, NVH performance of the car. And there's a matching between the marketing demand and the NVH performance. So there's at the beginning of any project, there's an agreement between performance level that has to be achieved, both subjectively and quantitatively. So it's a very fluid discussion between the marketing and us. And now they have their own subjective assessment canvas. We have our list of NVH performances, and we just connect the two and define benchmark, internal or external benchmark with objective target. And this is the definition of the project.
Okay, thank you very much, Laurent. I was just told that we have many questions coming from the net, actually, and these questions have been gathered by Nicolas Daucher. By the way, Nicolas Daucher is professor at the UTC Engineering School. So please tell us what kind of questions you have from the net.
Yes, thank you, Charles. Welcome, everyone. So yes, we have many questions. So we have one question from Arnaud Duval. Some of you knows. So what are the psychoacoustic criteria used to judge car sound quality?
As we are interested in the engineering process, we need to rely on figures. So we need to have objective indicators and objective indicators that can be easily computed from simulation or measurements. And in fact, really use very little of advanced psychoacoustic criteria. We mostly look at spectra with weighted spectra, dBA, dBB, and I would say the only psychoacoustic metric we use every day is the prominence ratio for the electric whining, which is quite common, and that's it.
Okay.
But it does not mean we are not interested in psychoacoustics, because this is a very pragmatic view to decide that we need to fix the threshold at a certain level. Maybe we have used in advanced studies, we have used psychoacoustic metrics, of course.
Great. Thank you, Laurent.
Okay.
Nicolas, any other question
Yes.
coming?
Another question, yes, linked to this one, more about subjective impression. So the question is, how do you collect the subjective impression of comfort? Not measure it, but collect the impression.
Collect the impressions.
So do you make subjective tests, and how do you do that?
Of course, there are subjective tests, because especially at the end of a project, because it has to be very fast and very global on all the different noise. We have about 40 NVH performances to handle at the vehicle level, which means few hundreds of requirement on components or subsystems. And of course, if you have to assess one development stage, you cannot go through everything. So we got some evaluation procedures, subjective procedures, but are correlated or tuned or very well defined. So we can be confident that if two different people, for example, make this subjective evaluation, we will have the same result.
Okay, thank you, Laurent. I have one question actually for you, coming from Isabelle Mauvarin, as I told you, who could not be here, but still wants to take part of this debate. So her question was, what is the limit between acoustic comfort and listening pleasure? What do you think about the difference, Laurent?
So for the European brands of Stellantis, ex-PSA, audio media is part of the NVH performances. So for us now, listening is really listening music in a car. And we don't have much customers interested in the real pleasure to listen the sound of the engine. This is really a high level sporty car issue. And unless you sell those kinds of car, there's no real pleasure. There's just try to reduce the noise. We just have a very little of sound enhancement, which raise a little bit the level of the engine and makes it more smooth in a way. But this is a very small part of the work.
Thank you. Thank you very much. From the audience, anybody else has a question?
Yes, we have some more question. So one question is maybe more technical, from Noémie Roche. Is, do you study different types of material in the car, such as structural materials, metal, composite, or different way of bonding these to the acoustical issues? So do you make the link between the material and the way you use it?
As I'm part of the vehicle synthesis, so we just provide the requirements at the vehicle level and the requirement for the components. And then we have dedicated engineering, mostly working with suppliers to define what will be the final solution to address a problem. Of course, we're involved in the process, because when we ask for a certain performance level, we have to be sure that we can reach this performance level within a budget. So we have to have some ideas of the solutions we will be using on the car. Okay, maybe it doesn't answer directly the question, but of course we know we have to assess what is proposed by the subsystem engineering, ensure that it's compatible with the requested performance.
Okay, so we have many other questions. Maybe a last one before we move. I can see Nicolas or
yes, we have maybe some more question, but maybe the question from Clément Dandivel. Some of you knows probably. So, do you share with us how the NVH and sound quality specification looked like 10 years ago? How they look like now, and how you expect them to be reshaped in 10 years? So, the question behind, he says, is there a generation effect?
Our requirement didn't change that much in the last 10 years. Of course, electrification raised new issues that will be solved, I think, very, very quickly in 6 years. We will have learned to handle all the problems related to electrification. And then an electric car is roughly easier than a combustion engine car, classical. So then looking at the level of the performance, in the past, there was differences between segments. The higher the segment, the lower the noise. The current trend is to have something that is more between quality level of the car. Premium car, even if small cars or large cars, they have higher performance, lower noise, and we may have also entry cars or over all segments. So there's not that much difference between the different segments. And generation effect in looking at the age of the customers. You have to know that the average age of new buyers of cars is quite old. So it's closer to 50 years than 20. So of course it's changing every year, as you may know, all of you. So we've not noticed up to now any clear change in the customer expectations.
Okay, Laurent, thank you very much for your explanations, also for your direct answers to the audience. We are on time, and we will move to our second presentation. That's going to be Matt Monder. As I told you, Matt Monder is a team leader in NVH and a technical specialist at Ricardo UK. They have been doing quite a lot of research on how to add sound, and that's interesting in the debate. So, Matt, the floor is yours now. You can present, and when you finish, we'll also have the same process of questions as we just lived with Laurent.
Can you hear my voice okay?
Very good.
Very good. And can you see the presentation?
Very good.
Very good. Excellent. Okay, so allow me first to just give a few minutes introduction to Ricardo, and to the noise and vibration team at Ricardo. We have a 50-year history, and we've got a well-developed process working on targets, concept studies, model-based development, and of course testing. And we are well distributed around Europe and also strongly in China as well, and with many people working on this topic. So now I'll come on to the main purpose of my talk today, which is to talk about vehicle sound enhancement. And what I would like to ask the audience is to consider what is the value of this sound enhancement. And I think Laurent Gagliardini sort of touched on this topic earlier, and I think with Stellantis, he mentioned that many of their customers are maybe don't expect or don't take pleasure from listening to the sound of the engines, and that is perhaps more for sporty cars. And I think that our realistic augmented sound system, RASA system, is kind of focused towards those sports cars, in particular electric sports cars, which is something we're seeing a kind of trend towards these days. And we think that those cars, although the natural sound of the electric machine is obviously much lower than an internal combustion engine, we do think that we do think that the authentic power unit sounds brought into the vehicle cabin can enhance the driver experience and also give a sound which supports the brand image of these sports cars. And similarly, the sound that can be reproduced outside the car can improve pedestrian safety as well, and also, again, convey the brand image to bystanders, perhaps potential customers, and that can certainly, we believe, impact and improve the sales of a vehicle. So there are 4 key features of our system that I want to briefly touch on, and then I'll show some examples after that. So first of all, we're using sensors in our system to collect live stream of sound. It's basically like a microphone, and that collects a live stream of authentic sound from the power unit, whether it be a thermal engine or electric machine. Secondly, we have a range of sound layers that can be used. So we can have a layer of sound based on the sensor, as I mentioned, which gives the authenticity. And we can also then bring in additional sound layers, perhaps to fill in any gaps in the sensor signal, and also to bring in different types of noises under different circumstances, under different operating conditions of the vehicle. Each of these layers can be tuned separately. And so, of course, the system does require some processing hardware in order to implement the real-time signal processing, and we're doing that with an embedded microcontroller at the moment. Potentially, the software could be ported onto in-car entertainment system. I think in many cases that is already done with perhaps simpler augmentation systems, and the sound quality is, as mentioned already, I think one of the most important vehicle attributes for sporty cars. It's part of the whole brand image, and I think that's historically been the situation. And I guess another question is, does that carry forward into the future as we move into sporty electric cars? And I think, for example, Porsche Taycan already exhibits, and perhaps some of the other newer products coming into the market already exhibit that. I think there is a demand for this type of sound, and let's debate that in a moment. Okay, so my next slide concerns really a case study, and what I want to do really is just I have to play the videos to you separately because they contain the sounds. So what I'm going to do is I'm going to duck out of the PowerPoint and work to the video file. So please bear with me. I hope this will work.
No problem. Go ahead.
I hope
It's
this will
okay.
work nicely. I think we tried it earlier and it seemed to work. So first of all, I'll play you the interior sound of our demonstrator car, which is a Nissan Leaf, before the sound system has been switched on. So I congratulate the Nissan engineers for doing an excellent job to reduce the noise level. Wind and road noise are well controlled in this vehicle. There's only the slightest hint of electric machine noise, and so it's very comfortable. But the question is it sporty? And I think the answer is, I think we can all agree that the answer is no, it isn't. So what I want to do is now play you this similar situation with the sound augmentation system running, which I hope will. Here we go. I think that's the same. I have a feeling that's the same. Oh, one moment. Here's the one. This is the one with the sound system running. Okay, let me play that one more time, and I'll try to commentate over the top as well. So at first we have a small acceleration. Which is audible, I think. And then a little steady and more acceleration. And then there's the overrun condition has its own sound there, the sound of the regenerative braking. So we tried to make sounds which are both natural feeling and also in line with drivers' expectations, that they fit in with the existing, the well-known language of car sound, so that these can be intuitively understood. Right. Okay. Now, next, just one moment. I will now share some exterior sounds as well. So likewise, first I will play the sound without the sound system running. A slightly wet day in the car park here. You can just hear the sound of the tires,
The rain,
and the rain, the water on the ground. But it's, again, basically a very quiet situation. So this is the sort of the danger situation in a car park. A car can now move with almost no sound, and that's why we have the AVAS legislation to make sure that electric machines do make some sound that can be heard by pedestrians to avoid nasty accidents. Now, so the next one I'll play is that is the sound with the sound system running. Play it again. So that's just a little bit of subtle sound. It's in line with the interior sound as well. We wanted to try and make it match in some way, but also to be subtle, so it's not too disturbing for people who are nearby but are not interested in the car moving, but can also provide a warning for those pedestrians who are nearby. Okay, so really that's the end of my presentation. So I open the floor to questions now.
Thank you very much, Matt, for this explanation. And it's so interesting to see that you guys are working on creating sound where there is no noise, for example, and the fact of not having noise could be a danger. So it's interesting for the debate. And another point of the debate that was very interesting is also the sound signature. And in this sense, I have a first question still from Isabelle Mauvarin, who I personally represent here. Isabelle was saying, are the NVH of an agricultural tractor and that of a Harley Davidson, well known, the same? Interesting question.
Yeah,
so what do you think about that?
It's a very interesting question, and it's clear. Let me speak about Harley Davidson first. So it's very clear that for that brand, the sound is a really crucial part of the brand image, and it's very recognizable. They tried to patent it at one time. I believe they're unsuccessful, but it's very distinctive sound, and it's very clear that is an important part of the brand image. Now, on the whole, for tractors, you would of course expect that there's a worker who's using the tractor for a long time, and he just wants to have a low noise level with minimum disturbance, so he can listen to music or whatever, or speak on the phone. And of course, then the requirements for those different products are different. However, having said that, I actually I started working in India on tractor sound, where in the Indian market, we're told, or the tractor manufacturer that I'm working with is absolutely sure that the tractor sound quality is also powerful sound is also really important in that market. So it depends. We spoke earlier about cultural differences, and those also are based to a large extent on cultural expectations, on exposure, and on different experiences that different people or different groups of people have using a product. So it's not always clear, and for sure, comfort we can talk about in a maybe a more quantitative manner, at least partly in terms of noise disturbance. But I think the sound quality is can be an important feature of.
Thank you, Matt, very much. Very clear. We have so many questions coming from the net, so I will ask Nicolas if he can tell us which are the most interesting,
Too many.
popular ones. to
Just
share.
for your information, there are something like 200 people listening to us. And so we have, yes, a question from Pierre Grenier. So just a question about the outside sound of an EV. Are there any information in the norms and rules? And so the next, the question is this system, Avast, I think can make more noise than for an electric vehicle than for gasoline vehicle.
Yes, yes.
Yeah. So
That is the case. So the ISO 362 R5103 does include. Maybe I've got that one wrong. That's the pass-by one, but I think that includes the Airbus as well. Does include a specification of the sound level in dBA that should be made at the exterior of the car. It also specifies some degree of frequency content, so that is specified. And yes, it is a bit louder than we'd hoped it would be, and I think there could be an impact on environmental noise, traffic noise in situ, resulting from this as the take up of electric vehicles grows in the market. And I think I can envisage that the noise levels that are regulated will probably have to be revised in the future as the fleet becomes more electrified.
Thank you. One more from the public, Nicolas? Or?
yes, question from Nicolas Misdaris from IRCAM. So how do you deal with acoustic interferences between the interior and the exterior sound in the same vehicle?
It's a difficult point, that one, because the exterior sound can be heard inside the car to an extent, usually. Now the speakers tend to be at the very front of the car and at the very back of the car, so that helps a bit because the distance to the cabin, to the receivers inside, the people inside the cabin, is greater. But yeah, that can happen. The interior sound doesn't usually impact the outside of the car very much, at least not under normal circumstances, because the sound level inside the car actually is very small. But yeah, so the exterior sound can break into the interior, but it's only at low speed. So what we try to do is to blend the two, the interior sound, bring the interior sound augmentation down a little bit in level at the very low speed conditions where the exterior sound can break in.
Okay, thank you very much. Anybody else for a question on the audience, on the round table? Yes, I can see Etienne Pariset has a question.
Yes, thank you, Charles. Thank you, Matt, for your presentation. I have a question regarding what I can say the long-term use of a sound enhancement system in the car. I mean, is the customer able to switch on and off the system?
Yes.
And if so, have you observed what the customers really do? Because your example show the alternative between noise comfort, because as you said, the Nissan car is very silent.
Yes.
And sound quality provided by your system.
Yeah.
So we could evaluate if people prefer noise comfort or sound quality.
Indeed, absolutely. Very good question. Thank you very much for that one. So there's the augmented sound that we're adding is, firstly, it's only a very low sound pressure level, and actually it does not impact very much to the overall dBA inside the car, only a tiny fraction. And secondly, we're adding those augmented sounds only during acceleration phases, or to a large part during acceleration phases, a little bit in overrun as well, but the sound of the battery recuperating, refilling. So the sound level is not actually very high. And the other point is that in the when the driver lifts off from the pedal, the sound level also drops. The augmented sound level drops very significantly. So in the cruising conditions, we should have basically no additional sound. So the cruising comfort is maintained. So going back to the question, could the user switch it off? Well, of course, that's technically possible, but our recommendation would be not to allow that. And that because the sound, we feel, should be an intrinsic part of the product. and intrinsically linked. If you can switch the sound off, then it becomes a kind of, it's clear that it's electronically generated, and it somehow loses its connection, deep connection to the car itself, to the behavior of the car itself. And that's really, I think, especially in the sports car segment, the authenticity is a really critical factor. And I think I would recommend not to allow the ability to switch off the augmented sound.
Okay, thank you very much, Matt. Very clear. I think we have plenty of other questions coming from the net. So, Nicolas.
Yeah, maybe a last question from Thomas Jean. So that listened to your video quite with a good ear. The second record is Sporty, but also seems louder. So we know that for interior noise, quieter is better at the end, maybe. Yeah.
Maybe,
so did you check this impact, and did you try to get an equivalent noise level with this Sporty effect?
Yeah, I mean, we checked the impact, and as I mentioned before, it's very small in terms of the overall sound pressure level. We don't want to cause discomfort. It's really about providing information to the driver and to pedestrians outside the car. So I think you could say quieter is better, but actually there comes a point when that perhaps isn't the case. And if you're in a very powerful electric car, like for example Tesla Model S or something like that, you can go very fast, and you don't have much sense of how fast you're going. And that, to my mind, that feels like a kind of actually a negative situation, and that if the car can provide the driver with at least a small small amount of sound that tells them that the acceleration is happening very fast, that improves safety, I think, not just for pedestrians, but also because the driver can feel how the car is behaving more clearly.
Okay, thank you very much. Another question, Nicolas, or a last question before we close this one?
Yes. Charles?
Yes.
Oh, sorry. I just would like to make a comment.
Okay, please go ahead.
Because our experience is a bit different. My personal experience about sound enhancement is that it changed the behavior of the driver, generally in the sense that he has a much more aggressive driving. And most of the experience is related to the fact that because of the noise, you drive faster. So this is really balanced. Sometimes we have some cars we are very not that comfortable with the result that makes you driving so fast that maybe it's not what you said about safety.
I think I can agree with you. I agree. I definitely agree that the adding the sportier sound kind of it does encourage a little bit faster driving, because there's a reward for it.
Yes. In your demo, you can notice that the acceleration is much faster with the sporty sound than what it was with no sound.
Yeah. And I guess you're right, for kind of a high volume mainstream car that provides a transportation function mainly, that probably is not appropriate. But if many of our customers in the automotive world are spending extra money because they want something which is somehow more special, and I think that the augmented sound can support that.
Yeah, in the sense of a signature for the car.
A signature. Thank you, Charles.
Okay.
Good word.
Sorry for disturbing.
No problem.
No, thank you, Laurent. It's a good comment.
So thank you very much. I think we covered this subject. Very interesting, Matt, that opened up really some reflections on different subjects. Thank you. I had the last question, but I will ask you personally when all this finishes. It has to do with money, and I can raise it, but don't expect your answer. But are people really ready to pay to have sound in their car? Maybe a good question. So maybe something for a debate later, because we'll have other floors for debate. So thank you very much. Now we will move to Fabrice Aubin. Fabrice Aubin is an NVH expert at SNCF. SNCF is a railway company in France. So that is interesting for us because it opens up the chakras a little bit to something different, so different experiences. So Fabrice, the floor is yours. You'll be able to share your screen. And when you finish, we'll have the same process of questions for debate.
Yes, thank you very much for your invitation. Everybody can see the screen?
Yes, we can.
The audio is good?
Very good.
Audio is important for acoustic expert. Very good. So firstly, thank you very much for your invitation and especially for the SII members. So it's a pleasure for us to present our work. So in my first slide, I would like to give you an overview about what we do at SNCF in terms of acoustic comfort. So if you look on the left-hand side, we have pictures which show different indicators that we use currently to specify some acoustic comfort inside the train. Obviously, we have a lot of questions at the beginning about what kind of indicator will be the best, what kind of tonality assessment can be used. So we have a lot of questions about these different acoustic indicators. And then once we make some good requirement, we have the test type. And during the type test, we follow the ISO EN 3381, which provide us some information about microphone position in different areas inside a train. So you can see in the picture that the common approach at the moment for the standard, so it's an ISO EN, so it's Europe and international. We have a recommendation to put microphone on a corridor, and we can put in different areas inside the train as platforms, upper and lowers, bar, and different area where you can make some different activities. And at the end, once you have done good requirements and the manufacturer follow what he can, we expect to have a good product at the end. So in terms of general context, passenger can perform a variety of activities, such reading, working, meeting in business box we can have, and watching movies. So we think that take a train during a long journey, it's a time that you can use as a spare time as well, or even for meetings and working. So for that, we said, okay, we should try to, or we must control our background noise to make sure that the passenger comfort is quieter. And for that, we have done several research projects done during several years. Projects have been done between a collaboration very, very strong between the engineering, so my part, and the research department at SNCF. We want to be very close together to understand what engineering can do and what can research department can do for me. That's very important. So during the first step, we make some a survey or questionnaire about to understand the annoyance for the passenger during a long travel. And during this questionnaire have been done during a travel inside the train, because we have seen that when you are inside the train, you need to take into account the vibe, the whole atmosphere inside the train. So we have to take the seats, the lights, the air conditioning, the trims, and we ask a lot of questions to the passengers. And obviously, at the end, we focus in different questions about acoustic. At the end of this question and survey, we have succeeded to make an analysis and define some key words in acoustic. So we notice that passengers take into account an annoyance due to conversation for people. It can be squeak and rattles. It can be intermittent source for different equipment, or even opening and close for doors. And of course, train background noise and different tonality for equipment. Then once we have done this questionnaire, we said, okay, we should try to do listening test, and we make some listening tests to try to understand which indicator can be used, dBA or loudness. And finally, after this investigation and research, we have seen a strong correlation between loudness, that it was better than dBA. In a third part, so currently we said, okay, we have seen that by a questionnaire, the relationship between the vibe of the train and the acoustic. Then we define that the annoyance was better correlated with loudness and dBA. And we said, okay, let's try to see what kind of activities that we do during the train can have an impact or due to of the background noise. So we launched a new project recently to try to define some threshold depending of activities carried out by the passenger, reading, working, watching video. And as well, I request to my researcher to take into account multi-indicators. We would like to use loudness and tonality assessment. So we try to have to develop a new full indicators, psychoacoustic indicators, to try to take into account tonality and loudness. That's an ongoing project. And to conclude, for the measurement part, we follow the ISO. So we have defined methods, conditions, indicators, but currently it doesn't include any psychoacoustic criteria. So we are a bit, we can say, stuck, because at the moment the standard doesn't give you some proposal, but according to our specification, we would like to start to put some psychoacoustic criteria like loudness and tonality in our own requirement. So to conclude, I would like to say thank you for everybody. And I had some reference paper that we wrote recently during the forum Acousticum.
Okay, thank you very much, Fabrice, for these insights. It's very interesting. It sounds like the railway industry is prefiguring what's going to happen in the automotive, because on autonomous driving, of course, we will be in a situation where we will do something else than driving. Then the question will arise how to manage all these acoustics based on the different use cases. So this opened up the debate. I could see a hand raising that on Anne Sanon. So Anne, if you want to raise your question.
Yes. As you talked, you made some tests with different seats, and I think about the different perceptions we have. Is the acoustic comfort depending on the direction of the body positioned inside the train? That means forward or backward?
To be honest, we haven't seen such difference between position of the seat, but we have seen a difference between areas in the train. Is that meaning if you change coaches, if you are in the front of the train or back to the train, you can have some difference. But in a local place, we didn't see a big difference.
Thanks. Thank you very much.
Okay, so maybe another question that I've seen saying, what are the difficulties for manufacturers to use psychoacoustic indicators, such as loudness, for example, from your point of view? Others may also share their views. So,
to be honest, I am part to the writing of the standard for the ISO 3381 as an operator. So, not to go in details, but it's a group who are writing standards. So we discuss about method, and we start to pop up this question about psychoacoustic criteria. And we had a very strong reaction. Finally, for them, if you change the method, if you had acoustic criteria and psychoacoustic criteria, you can change the whole method for them. Does that mean you will change the whole process for simulation? You can change the target for component level. You can change the target for the method as well for each sub-supplier. So it's a lot of effort for them, according to them. So is that mean you will change the methodology for the manufacturers, like highway field, but you can change as well the method for the component as a HVAC system, transformer. So it's the whole process will change. So for them, according to the manufacturers, it's difficult to introduce sound quality in our standards.
Thank you very much. I have heard we have some questions from the net. So Nicolas.
Yes, sure. So we have a question from Jérôme Boudot. So did you compare the noise in railway in other European countries or in Asia? So the question of other countries.
A very good question. We compare in Europe, clearly, yes, but not in Asia because we don't have too much data in Asia, and I'm not. I don't have been to Asia to make some listening tests, so I don't have enough experience in the Asia train.
Okay, thank you. Another question from the net, Nicolas or Rosen?
I think we have a question from Etienne also.
Maybe I have one question.
Yes.
Maybe it's to go back to car, to automotive acoustic comfort. If we see the future with autonomous car, and since the driver will be less focused on driving, and so it is cognitive task will evolve with autonomous car. From your studies about the impact of the activities of passengers to their perception of comfort, can we? These studies are they leading us to modify the criteria of acoustic comfort in autonomous car? What do you think of this? It's open question. Sorry.
Yeah, it's an open question. I think it's a good question because finally, automotive car and autonomous car without driver, so you will be in the same configuration in a highway. Finally, that means it will be a spare time for you. But now, spare time can be different for each people. This is the difficulty that we have because in a train, different passenger, you can have passenger who want to try to work. People want to do some meeting in a business box. We can have some people who want to reading, watching movie. So finally, we have different activities. So maybe in a car, maybe you will have maybe 4 or 6 people. So depending on the activities that you can lead inside, that will be interesting. Maybe you can propose some car to do some business box and make some meetings. So you have to control your background noise. Depends of activities that you will do in a car. Yes, it will be very similar, I think.
Thank you.
Thank you. Nicolas, I think you have one more question coming from the net.
Yes, a question with in line with what said before, how to create in a car a sleepy atmosphere for passengers and active atmosphere for driver.
So I prefer to give you a very positive answer for the driver. We have inside the driver cab, we have some alarms who generate some signals to make sure that the driver doesn't sleep. So this, safety is the first thing that we do, always safety first. And the second question for the sleepy, it's related to the questionnaire that we have done because sometimes sleepy is due to other people. So the annoyance can be generated by people around you. It's not the background of the train who annoy you. It's people close to you because you can't sleep. So that means you have to change the completely aspect. Maybe create some sleepy areas. Why not? In some coach, we can say, okay, this is area for sleeping. This is area for working. This is areas for watching movie. Why not? But at the moment, we haven't focused on this type of distinguished areas yet.
Okay.
Okay, so do we have any other question?
Yes, we have a question from Romain Barbeau. Have you developed vibration specification of subcomponents to ensure an overall comfort or acoustic performance? So the question of subcomponents.
It's a good question. The thing is, as operators, we define specification at train level. Does that mean inside the train? My job is not to define target specification at component level. This is the manufacturers must do the work. Of course, we can point out that some areas we would like to maybe focus that we want to have less vibration comfort to the seat, so we can put requirement in the area of the seat. But it's for us, we always discuss about train level performance.
Okay, thank you very much. So from this table, anybody else has a question? Yeah, Etienne has a question.
Yeah, thank you, Charles. A very, very short question. Fabrice,
Yes,
which
Etienne.
loudness model do you use? Because, you know, in the ISO standard, there are two models basically based from Zwicker's work or Brian Moore's work, and they may give rather different results in the very low frequency range.
Mm-hmm.
So I would like to know which model you use.
Yeah. So what we have done, firstly, the first studies about to define which indicator we should use between loudness and dBA. According to my souvenir, we use the Zwicker model. Because they have done some correlation between subjective evaluation, listening test, and objective measurement, and the Zwicker model was the one that was chosen at this stage. And then recently, we did another research campaign with Mr. Lemaitre and to deal about these activities, because for us it was really dealing activities threshold. And we make a lot of listening tests. We have been like maybe 78 people, and we request to the consultant to try to keep the Zwicker model, because this is something that we start to use. We didn't want to change again, because otherwise you will change your methodology every project. So we want to be aligned with our strategy to try. We start by Zwicker model. We would like to use Zwicker model, but we asked to the consultant to propose other model to see if maybe we have we forget something. So we said, okay, give us your opinion to the consultant. Try to check if you find different acoustic criteria with maybe the Moore and other model for loudness. And finally, according to the results, the difference was not so important, and we choose to use the Zwicker model.
Okay, thank you very much, Fabrice. We have so many questions coming from everywhere. We have more. Unfortunately, we're limited by time. So thank you very much
It was a pleasure.
for your insights, which really prefigures what's going to happen in the automotive. So now we will move to a more academic world with Professor Etienne Pariset, who is a professor at INSA Lyon. Engineering school. So Etienne will touch on what changes should be made to initial and continuing training courses. So this will be your floor now, Etienne. You can go ahead.
Thank you very much, Charles. So the basic for this presentation is that in most engineering trainings, acoustic courses are concerned with physics only, description of sources, sound propagation, and so on. I think it would also be useful to give students skills in sound perception. This knowledge is certainly important for acousticians in industrial companies. So the purpose of this presentation is to present what is done in this sense at INSA Lyon in a very low number of teaching hours. And I would also be happy to share the experience of others or to get some feedback from manufacturers who may need such skills. So the two key messages I want to give students are the following ones. First of all, sound perception or psychoacoustics is a science. You know, this is not so easy to admit for people from the engineering field. But if you conduct a listening test experiment, this is just a measurement. And as for all measurements, you can be confident in the results if the experiment was made with care. And also the so-called psychoacoustic metrics have been derived from validated modelization of the hearing system, at least for some of these metrics. And the second point is that the knowledge derived from psychoacoustics can really be a useful tool for the acoustic engineers, in addition, of course, to the knowledge of physical phenomena, which is necessary undoubtedly. The content of the course is as follows: a presentation of the auditory system, including some physiological data, because some of these characteristics are very important for the following, and also because the auditory system is really fascinating. And then I present some very important perceptual phenomena which are taken into account in the various metrics. The focus is given on loudness, and we do a very short experiment of loudness magnitude estimation. I do like the experiment because we do it in a very poor conditions in the classroom, and so well, not so many students, maybe between 10 and 15. And despite that, we always check that Stevens law is respected, as you can see in the diagram. You know, these are the results we obtained this year, and the exponent of the law is really quite close to the expected one. And then students do some practical work. They are given a set of 8 sounds recorded from 8 car components. They perform a listening test experiment to evaluate the pleasantness of the sounds as well as loudness and sharpness. Then they are asked to use various metrics using a classical commercial software. And these metrics are supposed to represent loudness and sharpness, and we ask them to think about the validity of these metrics. And also to get some knowledge about the use of these metrics. For example, 2 sounds have loudness values of, let's say, 28 on 30 sounds. Is this difference significant? The answer is not so easy for the students because loudness values are given according to a ratio scale. So the difference is not really the good value to observe. And to go a little bit further, I want them to discover the usefulness of the metrics. For example, given this sound spectrum, which part of it contributes most to loudness? The specific loudness curve in red here clearly gives the answer. For another component, which sounds rough, where does roughness come from? The specific roughness curve in red show them that it should be somewhere around 2 kilohertz. So, you know, coming back to an answer given by Laurent at the very, very beginning, I think these are very simple figures. If you look at the specific loudness curve, it's a very simple figure which can be very easily obtained from measurements or simulation. So the answer showed me that there is still a lot to be done to demonstrate the value of these methods in the industry. Okay, so finally, students are asked to modify a sound in order to make it more pleasant. They can filter the sound as they wish by real-time filtering and listening. The limit is that the overall sound level should not be reduced by more than 2 dBA. And this is a kind of challenge because at the end, there is a second listening test experiment in which students evaluate all the modified sounds as well as the original one. You can see here the results obtained this year. Nearly all students actually increased the pleasantness of the original sound. The original sound is here, and each number represents a student. And there is a clear winner of the challenge, student number 9, but all of them appreciated this kind of challenge. Okay, so this is an overview of what I would like students to keep in mind. Some basic ideas about on other metrics than sound pressure level, and also that listening to sounds is necessary. The perception of the sound cannot be fully predicted from the spectrum. That's it. Thank you for your attention. And once again, any comment or description of another teaching experience would be appreciated.
Okay, thank you very much, Etienne. Very interesting insights, because here also on the floor, we don't only have yet professionals, we have also many students. But I would have a personal question to know whether actually concerning sound perception, what type of background would you need in terms of profiles from the students?
I think they just need very basic knowledge about signal processing, what the spectrum is, what filtering of a signal consists in, and that's all.
Okay. Okay, anybody else to ask a question on the floor?
Attends, je te vois plus, je te vois là, hop. Non, ça marche.
Nicolas, I remember you have a question concerning
Yes, we have some
personal
questions.
question.
Yeah, we have a question here from the net from Isabelle Chailly-Monvarin. So when looking for a correlation between psychoacoustic metrics and subjective perception, do you recommend subject testers to have made an audiogram in order to calibrate the listening measurements?
Yes, so we always measure the hearing ability of people who participate in our listening experiments. But it's just in order to be able to understand some kind of very strange individual result. Sometimes we can explain this kind of result because it appeared that the participant have had some listening problems.
Okay.
But that's all. And we are not very strict indeed, you know, hearing threshold of 20 dB is correct.
Mm-hmm.
In that sense.
Okay.
Okay. I have another question, maybe more general. What do you think about metrics? Can we trust the metrics that are proposed in sound quality softwares? Can we use it as it?
So the basic message I give to students is that from my point of view, we can really trust loudness. Loudness models are really reliable, I think. Also sharpness models. I think we should be much more careful with roughness models. There are many roughness models. Not all of these models are clearly explained, and I was often disappointed when I tried to use these models. Tonality, for example, very surprisingly, arrest tonality proved to be very efficient, I think. I mean, I say surprisingly because the model is quite complex and I did not understand how they could derive such a model, but it proved to be very efficient.
Okay.
But you're right. Sorry, you're right. We should not trust all the metrics.
So you have to make your experience and make some tests, maybe in parallel, some subjective tests to be sure that your metrics are adapted to the system you are studying.
I think so, yes.
Okay.
I have one question here from Anne Sanon. I can see. Try to raise her hand.
Yes, in fact, you talked about signal processing, but for me, I'm using loudness every day. And what is very, very interesting with the usage of these metrics is the statistical analysis that comes with it. It's very easy to make a statistical analysis on these metrics, and the correlation with the word correlation itself with jury evaluation is very important. So I think what is your feeling about these noises that depend on how you activate something, or that are not always the same because of the weather conditions or things like that, and we can have a really whole a great feeling? What is your
sorry, I did not understand your question.
What is your feeling about the ability of these metrics to take into account weather conditions, different driving conditions, and things like that?
It's a difficult question, Anne. Thank you very much. So for unstationary noise, you know, the situation is a little bit more complex, and I think metrics can really give you some useful information about the kind of instantaneous perception of noise. But for example, if you have a component which can create a lot of different sounds depending on weather conditions and so on, I think the question, it's very difficult to have a metric which can really represent the overall evaluation a customer can have about that product.
Okay.
You know, okay, sorry, Charles. It's time to
No. Thank you very much. It's okay. We have more questions coming from the net, I think, with Nicolas.
Yes. Before I can make a comment also to answer the question of Etienne that said, if you want to share your experience, your teaching experience, so I just can say a word about that. So at UTC we also have a course called Acoustic Design for all the students of UTC, and the idea is more for them to have the experience of sound listening. So, when we have two projects in this course, which is analysis of sound of technical product like car doors or microwave and whatever, and one other project is producing sound for instance for your mobile phone, what kind of sound. So we have both the both approaches to try to make them be more attentive to the sound of the products they are working on. Just so that was my comment. And so now we have also some
I have a question, Nicolas.
Yes.
How many teaching hours?
It's something like so we have 12 hours of course and 24 of practicals.
Okay, so it's much more that.
Yeah.
In my case, okay.
Okay, and so we have some other questions. For instance, about the sound perception in a car or train cabin. About the index, the STI, the sound intelligibility. So, do you have a comment, Etienne, about that index, sound intelligibility?
I know it's often used to evaluate some kind of sound level in the middle frequency range in the car industry. I think in train, by Fabrice could give her the answer. It should be very useful in train because of privacy problems.
So it's a question that pop up recently in terms of intelligibility and privacy, especially in some business box. So in some area, we would like to have some area for meetings. So we want to make sure that inside the meeting rooms, people can discuss easily, okay, and with a good intelligibility index. And but with that, we want to be sure that outside the business box, people doesn't hear the conversation. That's something that we have to check. It was not so easy. It's not done yet, but it's still some discussion about how to deal about privacy in meeting rooms and outside, how to select the areas, because finally in a coach or in a car, we said we would like to have a kind of modularity inside the coach. Does that mean you can change your cars between what do you want to do? You want to do today you have a request for the passenger to do business box, or tomorrow you will have maybe more passenger people, so you don't need this business box anymore. So you have to adapt depending of the functionality and the expectation of people.
Okay, thank you very much. I think we have one more from the public, Nicolas. One more
yes.
selected. There are many others, but at least we have
in fact, it was a question from Nicolas Schwarz for Fabrice Aubin, but
yes.
I think it's connected to what we are talking about. Is regarding spoken communication. So did you try to compute the listening efforts at different places, and what kind maybe of indicator can you use for that?
Yeah, thank you, Nicolas, for this question. Yes, with Mr. Lemaitre, and we currently discuss about, it's an ongoing project, but we were thinking about what kind of background noise level will be the best to have a conversation one-to-one, and is that mean in like one-to-one seat at 1 meter roughly between two people. And so we were thinking about using STIPA index, but that means you will calculate intelligibility index, and you will try to make a target for the background noise to make sure that the conversation is properly listening and hearing. Okay. That's really ongoing. It's very fresh. You have to wait a few months, and I hopefully will have some good result to present in a next paper within the group.
Okay, so thank you very much. Do you have a last question, Nicolas, or is it okay now?
Yes, we can have a last question.
Okay. Have a last
for Etienne, I guess. So I often use the ISO to calculate the time varying loudness for transient sound, and consider it to work well. So, what did you try that, Etienne? Or what do you think about that for transient sound?
I agree. It works quite well for very short stimuli. Coming back maybe to the question from Anne. But for very short stimuli, many years ago, I used that model to evaluate the sound quality of door closer sound in cars, and it proved to be very interesting metric. It was very well related to the auditory impression of participants and to the sound quality. I recommend it.
Okay, thank you very much, Etienne, for your good insights, and we have so many questions. So I believe in the next steps of discussions, we'll be able to put that on the floor again. So again, thank you for your time, for sharing all this with us. So now we will move to the last part of this webinar, which is focused on China. So to do that, we have invited Ming-Su. Ming-Su is a senior NVH expert at Valeo China, and will give us some flavor about China and explain some facts that are interesting to capture within this discussion. We may not have so much time for discussion in the end, but still a little bit, and we will manage depending on time left. So Ming-Su, this is your floor. You can from now start anytime your presentation. I hope connection with China is good. Ming-Su, can you hear us? No, we can't hear you. We see you, we can't hear you.
Okay, I'm mute, sorry.
Yeah, now it's coming.
Hello, do you hear me?
Yes, very well. Very well.
Okay. Hello, thanks, Jas, and also thanks for see. So I will introduce the vehicle which comfort group. The first, I got some data from the top 10. We can find there for Chinese end user, they have so much complaint for the edge sites linked with the excess loud noise, excess noise and no noise, and also for the fan blower, excess noise and blockade noise. Also in the we are found there in the European, they also have some the similar ones not work, not so much link with the noise. So in here we can find the Chinese markets and the user more sensitive for the noise. Maybe link with how to say was the temperature needs is different. So in next page I will introduce why they have complaint for the fan or blow noise. So in here we can find the temperature in the summer and winter for the Hamburg, Paris, and the Chela Tianjin. In here we can find the lower temperature in the Chela, lower than the European. And in the summer, for the high temperature, we are higher than the European. So means we are more summer needs for the summer comfortable. In this area, linked with the HVAC side, we need more airflow for the thermal exchange. And also during this phase, almost the car windows will be always closed. So this is why the noise will be the complaint so much. First, the overall noise will be high. Second, during the car windows closed, though the acoustic mask background noise. So this is for thermal needs. So we need to consider the Chinese market needs more high level. And another is linked with how to say note quality. We have got some data from the published documents from the government to find the different levels for the load. The first ground load, the first loads is means the heavy load. The third is for the high quality loads, but about 17% is the foreground load. This load means why bad quality. They have so much vibration and in the car body, transfer to the car body, and then higher level the noise vibration will be with the wide frequency impact to the car body and then transfer to the car inside. Also, the car body, the vibration will be transferred to the HVAC and all other components. So in this area, the squares and the rating noise will be inside. This will be impact for some components in vehicle capacity number. And also, I think another maybe not linked in this side, how to say, in the channel always will be block on the road during the niche phase. How to say, the passengers, the feeling is not so good. So during the niche phase, only the noise will be make the complaint from end user. So this is my opinion. So thanks attention. So thank you. So this is my presentation.
Sorry, my mic was cut. So thank you very much, Min, for your presentation. It has given us the chance to see that, well, the conditions are very different in China in terms of amplitude, thermal. The road conditions are different. The usage also within the car is different with windows open. And that is the parameters that actually enhance a lot the demand for sound quality and acoustic level in China. This is absolutely interesting. I know that Said Naji, who is also one of our acousticians at Valeo, wanted to intervene. I can see you, Said. If you have any comment to do, also the floor is yours.
Okay, so thank you very much. I'm Said Naji. I'm NVH Master Expert at Valeo also, and I'm working so much every time with Minzu. That's why I think that everybody didn't hear very well what is Minzu wanted to say, because the communication with the net is a little bit difficult. So just for me to summarize a little bit, what I understand from his communication is that finally the problem of subjective evaluation of some noises or feeling of comfort, it's not linked to, let me say, for me and for him, to the culture, but it's just linked to the conditions of, for example, driving or temperature or something like this. That's why it can be very interesting debate between all us to see if if he is right or not. So we are waiting for your question. Thank you.
Okay, we have some questions, Said. Thank you very much from the net. Many questions coming. So maybe Nicolas, you can walk us through some questions.
Yes, we have a question from Jean-François Rondeau. So beyond temperature and road condition, what are the main differences between the end users' NVH expectation in Europe and Asia? So I don't know if Mingzu or Said can answer to this question.
I will answer, or just give one words to debate. Once again, what Minzu wanted to say is there is no difference between European and Chinese people. There's only the conditions. So for me, if you drive your car and you are in bad road, you will not be happy, even you are Chinese or European or African or whatever. That's the answer.
Okay. Thank you.
Other questions that showed up from the net? Nicolas?
Yes, one question. Can HVAC ANC be one solution to improve ventilation noise at maximum speed inside the cars? So ANC, noise cancellation, active noise
Yeah.
cancellation.
Okay, I can answer because this is my job daily. Very interesting question. Yes, sure. But you know, it's the part of the cost. If the cost is negligible compared to, let me say, the product itself, yeah. And something else is that I'm not sure. I try to different, yeah. I transfer time to make it happen on HVAC, and the problem sometimes is, first of all, of course, cost, but also don't forget the packaging. And when the packaging, we have to take packaging to solve, let me say, some HVAC noise. I prefer to take this packaging to make or to have less pressure, because as you know, HVAC noise is coming from pressure and airflow. I prefer to use this packaging to reduce the pressure, then I can reduce the noise. Second thing also is that also if we can reduce the noise at the level of HVAC, but at the end we need to make, let me say, noise cancellation inside the car. This is the answer for me.
Mm-hmm. Okay. So maybe just a short question.
Okay.
For all of us, because we had discussion already before. So what is the price of the dB, of 1 dB? 1 dB less, how much euros? So maybe it's everyone can answer, and we can mean the result at the end.
Laurent, can you tell me?
Yes. That easy. €0.
Zero.
Just there's no demand for improvement of the performance at the moment. So every time we want to innovate, propose ANC, for example, we have to show that it decreases the overall price of the car. This is our everyday job, showing that with, for example, ANC, we can decrease the overall cost of the car, which is possible, by the way. That is what makes the job fun.
Yeah.
But €1, no, it's too much.
Yeah. Okay. Somebody can also, because I have my answer also. I prefer that everybody speak, then I will answer.
Okay. Any other reactions, questions to this audience on the table?
If not, I can answer to the question of Nicolas. You know.
Yeah, please go ahead.
So, as Laurent told us, of course, nobody wants to pay for to reduce the noise, but there are some who use this. Let me say, to use the dB to put some penalty. So in this case, there is a cost. I mean, we pay because we are not at the good level, but we never pay, or customer never pay if we are at lower level. This is the answer. And sometimes it's very, very, very expensive, the dB, you know.
Mm-hmm.
So.
Okay. Thank you very much.
You mean it's very expensive if it's above the threshold?
Yes. Yeah. Okay.
Good. Do we have other questions coming from the net, from the round table? Anybody would like to say something? Because now we are touching to the end of this webinar. Floor is still yours. One time, two times.
Maybe one last question.
Okay.
Quite technical. How many kilogram per dB in the low frequency? So does the low frequency cost a lot in terms of weight? So the problem of weight versus the acoustic level. So
So,
who wants to answer this question?
Yes, same answer.
Laurent?
Same answer. Every generation of the car, we are requested not to change the performance and decrease the mass by 10, 15, 50 kilograms sometimes. So the trend is to decrease the mass. Of course, not to decrease the NVH performance. Because the problem with NVH, once people are used to, the marketing people, they will never come back. So once they've listened a good car or a car with quite low level, they say, okay, it's how it should be. So the next one will be exactly the same, no discussion. But on the other side, we are requested to decrease the mass. So we have to engineer the body and try to master, control the design in a way we achieve the same result with a lower mass, which is at the moment still possible. Of course, there's a limit. But this is why we have so many people in NVH department in the car manufacturer, just to improve the engineering, to improve the overall balance of the project. Less mass, less euros, same NVH performance.
Okay.
Okay.
So
yeah.
So there are many challenges for our students in acoustic. So we invite them to go in that field.
Yes.
So that was maybe the word of the end. So I would like really to thank you all for the webinar. First of all, to thank the audience. We had so many people who connected from everywhere. So thank you very much for having been with us. Thank you to the presenters. Your presentations were of highest interest for debates, at least. We have so many questions that were not treated. So that is the reason why we will invite you in the next step. The next step being the, what is it called again? The GIFSFA, so Journée d'Industrie de la Société Française d'Acoustique in June. That means these are the days that will be dedicated to acoustics in June. A next step will be again not a webinar this time, but a congress, and we all hope with the COVID that it will allow us. That will be in October for the NVH Congress by the SIA. So that will give a further chance to debrief all these questions that could not be raised, all the topics that needed to be discussed, and will give a further flow to all the presenters to discuss with the public. So to finish, really, I would like to, again, I think very important to thank the people who were not visible in this preparation, because I know that this has taken them so much time, and in particular the scientific committee of the SIA. So I would like to cite people such as Hervé Pichon, such as Krasimir Tredax, such as Nicolas Daucher, who finally came with us from UTC, such as Louis-Ferdinand Pardo, Pascal Bouvet, Jean-François Rondeau, Saïd Nagy, of course, and Charles Pezra to finish. So all these people, you did not see them, but believe me, they did an excellent job to prepare that this webinar in many sessions and to make it a success for you. So I wish you all the best, and I hope you liked it, and see you in the next steps, as I said, GISFA, and also for the NVH Congress in October. Thank you very much, and goodbye to all of you.
Thank you.
Yes,
Thank you.
Thank
Bye-bye.
you.
Thank you.
Bye-bye.
Goodbye.